This is Mr. Precella in my Math 1332 online class, and we're working with some basics of probability theory. Hopefully you've had a chance to read in the book, and I'm doing some homework examples. And the first one we're doing today is going to involve rolling a pair of dice. Okay, if you just rolled one die, the outcome would be a 1 through 6. Well, what if you rolled two dice? What would the outcomes be? Well, we could think of them as ordered pairs. If you're rolling two dice, think of them maybe as one being red and one being white, so you can distinguish between them, okay? You could roll a 1 and a 1, okay? Or a 2 and a 1, a 3 and a 1, a 4 and a 1, a 5 and a 1, or a 6 and a 1. That's all the ways you could get a 1 on the first roll. Now, what about getting a 1 on the second die? To get the other ones, you could roll. Okay, so 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. I'm just writing out all the possibilities that you could get. This column here in purple represents where you would have rolled a 2 on the second die. 1, 2, 3, 4, 5, 6, and a 3 on the second. See, if you're rolling a 3 on the second die, you could roll anywhere from a 1 to a 6. Or you could roll a 4 on the second die. I'm thinking of these outcomes as ordered pairs. You could roll a 5 on the second die. 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. And finally, you could roll a 6 on the second die. By the way, die is singular, dice is plural, 1 die, 2 dice. Did y'all know that? Now, if we look at this problem we're going to do, a pair of fair dice is rolled. What's the probability of rolling a sum of 10? Well, altogether there are 36 outcomes here. So we want to know, out of these 36 outcomes, how many of them have a sum of 10? Well, if you look at the diagonals, right here, these 3 have a sum of 10. Like right here, that's a sum of 9. If you started, sum of 1 and 1 could give you a 2. Here are the 2 that could give you a sum of 3, a sum of 4, a sum of 5, a sum of 6, a sum of 7, and so forth. So there were 3 out of 36 3 ways of rolling a 10 out of 36 possible outcomes. So altogether, the probability of rolling a sum of 10 would be 1 out of 12. So that's the answer for the probability. Then part B says, okay, what are the odds against rolling a sum of 10? Well, did y'all read about odds and see it in the video? Odds are different from what was I about to say? Odds are different from probability. What are the odds against rolling a sum of 10? Let's first of all write the odds in favor. The odds in favor of rolling a sum of 10. To calculate the odds in favor of rolling a sum of 10. That's not what we're asked. We're asked for against. The odds in favor of rolling a sum of 10. You go, it's how many ways can you roll a sum of 10? Well, there are 3. 2, how many ways could you not roll a sum of 10? Well, there were 3 ways you could get a sum of 10. How many other ways could it possibly happen that you don't get a sum of 10? Well, 33. So 3 to 33. It should be noted that with odds, these two numbers should add together to give that bottom number. Here's how many ways you could get a 10. Here's how many ways you can't. Now we reduce odds the same way we would reduce a fraction. So we wouldn't say 3 to 33. We could divide both of these numbers by 3. So here's the number of ways, or here's the odds in favor of rolling a sum of 10. But what we're asked for are the odds against. So reverse these. Okay, the odds against rolling a sum of 10, 11 to 1. The 1 to 11 are odds in favor of rolling a sum of 10. So, do you want to think of it as 33 to 3? There are 33 ways you could not get a sum of 10, and then 3 ways that you could. If you click on View an Example, or maybe you saw this in your book, there's a little table there that shows you, okay, to get a sum of 2, a sum of 3, and so forth. Okay? But the way I wrote it out, you look at the diagonals like this. Okay? Let's see. What's our next one? Okay, number 6. One card is randomly selected from a deck of 52, from a standard 52 deck card. 52 card deck. What's the probability of drawing a heart? What are the odds against drawing a heart? Okay, well, probability of drawing a heart. Let's see. Here's a deck of cards. There are 4 suits: hearts, clubs, diamonds, spades. Then we have the aces through 10. Okay, those are the 10 non-face cards. And then jack, queen, king. Each suit has 3 face cards. Okay, so all together, to answer the question, what's the probability of drawing a heart? There are 13 hearts out of 52 cards. So this first answer, 13 out of 52, which we can reduce by dividing above and below by 13 to get 1/4. 1/4 of all of the cards are hearts. 1/4 are diamonds. Which one's diamonds? I've had a hard time seeing. Diamonds. 1/4 spades, 1/4 clubs. Now, what are the odds against drawing a heart? Well, how many non-hearts is going to be the number of non-hearts to the number of hearts? And then reduce. Well, there are 13, 26, 39. There are 39 cards that are not hearts and 13 cards that are. Notice these two numbers add together to give the bottom number there. But we're not going to leave it as 39 to 13 because we can divide both of those by 13 to get 3 to 1. Okay. I'm going to remember where this picture is in case there's another problem with the deck of cards, so I can look at, pull it up and look at it. Let's see, number 7. Oh, some sort of table here. The residents of a small town in the surrounding area are divided over the proposed construction of a sprint car racetrack in the town, as shown in the table on the right. If a newspaper reporter randomly selects a person to interview from these people, what is the probability that the person supports the racetrack? What is the probability the person supports the racetrack? Well, let's see. We better go ahead and add up all of these. How many people support the racetrack? If I add this, it's going to be what, 5,040? Let's add this column here. Is it 4,032? So I'm adding up those two columns. So how many people were interviewed total? There was a total of 9,072 people. Okay. Now, let's see. What's the probability that the person supports the racetrack? I'm going to write the answer right here. Well, out of the 9,072 people, there were 5,040 that supported it. Out of 9,072. So 5,040 over 9,072. We're told to type an integer or a simplified fraction. So I'm going to reduce that fraction using the math key on my calculator rather than just dividing. Let's see. We have 5,040 divided by 9,072. And I'm going to click right here, math. Might be hard to see that. And the very first thing says arrow to fraction. That means convert it to fraction. Enter. Ooh, can y'all see that? What is it? 5/9. So that's a nice little easy way to reduce the fraction. So what's the probability that a person supports the racetrack? 5/9. What are the odds in favor of a person supporting the racetrack? This is a good problem. We already have the probability, okay? So how can we convert this probability to the corresponding odds? Well, if we wanted to, we could reduce it like this and say, okay, it's 5,040. That's how many want the racetrack. To 4,032. That's how many oppose it. Now I could reduce that using that same fraction key. Just reduce it as if it were a fraction by punching in 5,040 over 4,032. I hit the little division key to get that fraction thing there. Math. I'm clicking math. Enter 5 to 4. So notice this. These two numbers add together to give that bottom number. So to convert a probability to the corresponding odds, the probability that the person supports the racetrack is 5/9. The odds in favor of a person supporting the racetrack is 5 to 4. Now if it asks what are the odds against, then you'd reverse it, 4 to 5. Okay? Let's see, problem number 8. Assume that the table below summarizes a survey involving the relationship between living arrangements and grade point average for a group of students. So 98, they interviewed 182 people who lived on campus. Here are their grade point averages. They interviewed 63 people that lived at home. Their grade point averages broken down. The apartment, and here's totals. So the totals are already there. So altogether, how many people did they interview? Well, 319. Okay? If we select a student randomly from this group, what is the probability that the student has a grade point average of at least 2.5? Well, at least 2.5 would be 2.5 or higher, wouldn't it? At least 2.5 would be 2.5 or higher. Well, we're looking at this whole group, so there's 319 people altogether. How many of them have a 2.5 or higher? That would be the 110 plus 27. So we have a 137 over 319. The instructions say type an integer or a decimal rounded to 2 decimal places. What that means is you're supposed to divide this with your calculator. And if you get an integer, then you put that in. Otherwise, if you get a decimal, you round it to 2 decimal places. 137 divided by 319.429. So rounding that to 2 decimal places, it would be 0.43. And that's what you would type in the box. Oh, here's another one. Table problem like that. Okay. A table of marital status for males and females is shown below. What's the probability that a divorced or separated person picked at random is a woman? Well, let's see. Do they give us all the totals here? No, they really don't, do they? Okay. Table of marital values is shown below. What's the probability that a divorced or separated person, we're looking at this column, what's the probability that a divorced or separated person picked at random is a woman? Well, we're going to need to add this. We need to know how many people are divorced or separated. Is that 4,034? Am I doing that right in my head? 14, yep. Yeah. So there's 4,034 divorced or separated people. How many of them are women? Well, 2,599. This is another one where it says, okay, round it. Write either a decimal or two, write either an integer or a decimal rounded to 2 decimal places. Well, when you punch that in, you sure don't get an integer. You get a decimal, so it's going to be a 0.644. Would it be just 0.64? Number 10, just sort of flying through these. Number 10, a table of marital status. Same type of table, just different numbers. If a never married person is randomly picked, so they're going to pick a never married person, what's the probability that the person is a man? Well, we need to know how many of these there are all together. Oh wow, there's a lot here. Is it 42,803? Let me see. Yeah, 42,803. I've added these. So what's the probability that the person is a man? Well, there are 23,650 men out of the 42,803 people that have never been married. So punching that in and getting another rounding to 2 decimal places, 23,650 divided by 42,803, 0.5525, rounding to 2 decimal places, 0.55. Number 11. If the odds against event E are 3 to 1, what's the probability of E? Well, let me see, where's that problem? Right here, referring back to this type of problem. This was the probability, and this was the odds in favor of the event. The probability of the event E, the odds in favor of event E. Notice, this number is the top one. The bottom number is the sum of these two. Well, this is the odds against event E. So we need to know, in order to calculate the probability, we need to know the odds in favor. The odds in favor would be 1 to 3. So the probability of E, the top number is the first number. The bottom number is the sum, 1/4. Okay? But you've noticed you've got to have it, the top number is the first number when it's in favor. Since this says the odds against, you're going to have to reverse the 3 to 1 as 1 to 3. Now, number 12. I'll use green. It says the probability of event E is 0.33. What are the odds against event E? Well, okay, so the probability that E happens, let's write that 0.33 as a fraction. It would be 33 over 100. So now let's write the odds in favor of E. And if we write the odds in favor of E, then once we find those, we'll just flip them to get the odds against. So the odds in favor of E, the top number is the first one, 33, 2. Notice they're using colon instead of the word 2, which is frequently done. This second number should add up to give 100. Okay, these two numbers should add together to give that bottom number. So what am I going to do to get this number right here? Well, subtract. 100 minus 33 is 67. Notice how these two numbers should add together to give the bottom number. But those are the odds in favor. We want against. So reverse them. 67 to 33. Now, you'll notice I didn't try to reduce these. There's no number that I can divide both of these by. Okay? 3 and 11 don't divide into 67. That's why I didn't put it into my calculator and try to to reduce it. Okay? Any questions? You'll see how I got the odds against. If it had said the odds in favor of E, then it would have been 33 to 67. You see my logic on how I got the 67? This bottom number here should be the sum of these two numbers here. So this number right here had to be 100 minus 33. Let's see. Oh, what's this? Let's see. Can y'all see that? Suppose the probability that a certain team will win a sports competition is 0.40. What are the odds in favor? And then what are the odds against? Oh, that's a really good one. Okay, so the probability that a team will win is 40%. So let's write that as a fraction. Excuse me. It is 40% or 0.40. Well, to write that as a fraction, it would be 40 over 100, which we could reduce by dividing above and below by what, 20? 2/5? Okay. If you have a hard time, okay, how do I get that fraction here? If you wanted to, if you have a calculator like this one, just use that key I was showing you. Put in 0.4, math, enter. See, 0.4 or 0.40 is 2/5. So now we want to know, that's the probability of them winning, so we want to know the odds in favor. That would be 2 to what? This second number better add together to give the bottom number. 2 to 3. That's the odds in favor of them winning. The odds against the team winning, well, just switch those, reverse them. 3 to 2. Okay. Odds in favor of them winning are 2 to 3. The odds against them winning are 3 to 2. Okay. So this is our first section over probability theory. Hopefully you've had time to look through the assigned reading, the book, and watch the video. And these were some homework examples I've worked for you. And we're out of time, so we will pick up and do more probability the next time. So thank you very much for watching. Bye-bye.